A small spiral of cosmic fire twists in the depths of Scorpius. What appears at first glance as a faint smudge of light becomes, under the gaze of powerful telescopes, a galactic theater of violence and rebirth. IC 4623, barely known to the public, conceals an intricate structure. Faint arms, disrupted by ancient forces, wrap around a dusty core that glows with infrared echoes. Observations from the James Webb Space Telescope unveil filaments of interstellar matter weaving through the central bulge, as if the galaxy is cocooning something deeper, a supermassive black hole, perhaps dormant, or quietly feeding behind veils of dust. Mid-infrared light reveals pockets of dense gas collapsing under gravity's pull, triggering hidden bursts of star formation invisible in optical wavelengths. This galaxy is not chaotic, but carefully unbalanced, caught in a long dance with gravitational forces we can only infer. Further across the sky lies a more ferocious heart, the galaxy NGC 6240. It burns not with light, but with violence. What was once two distinct galaxies are now one writhing system, their cores locked in a death spiral. Each core hides a black hole, and both are active. The space between them is seething with gas torn apart by tidal forces, ignited by shock waves, and lit up in X-ray emissions. Chandra and JWST together have painted a portrait of chaos. Enormous wings of ionized gas stretch outward like scars, while the double nuclei blaze with radiation strong enough to penetrate clouds thousands of light-years thick. Starburst regions erupt at the edges where the tidal streams compress interstellar matter, birthing stars at an unsustainable rate, like a final flash before collapse. The combined mass of the black holes, their mutual orbit, and the outflows from the central region suggest that NGC 6240 is a preview of what will happen when the Milky Way and Andromeda collide, a future snapshot from a scorched past. The signatures of heavy elements in the central regions reveal that generations of stars have lived and died here, enriching the galaxy's gas with oxygen, iron, and silicon. These traces are carried outward by galactic winds driven by the twin black holes, seeding the intergalactic medium with the ashes of creation. But the story of NGC 6240 does not end with destruction. It is also a laboratory, one of the clearest windows into how galaxies evolve through collision, feedback, and cosmic recycling. In the very center of this turbulent system, the two supermassive black holes spiral toward each other, distorting spacetime itself. Their mutual orbit is tightening, emitting gravitational waves too subtle for our current instruments to detect, but they serve as a foreshadowing of the cataclysm to come, a black hole merger that will unleash a final, ultraviolet ripple through the fabric of the universe. When that moment arrives, it will briefly outshine every star in the galaxy. The regions around the nuclei are turbulent beyond imagination. Molecular gas, instead of forming stars, is being blown outward at speeds of up to 1,000 kilometers per second. Observations in CO and HCN lines show that entire reservoirs of star-forming material are being ejected into space, a phenomenon known as quenching. Ironically, the very act of starburst and black hole activity might be dooming the galaxy's ability to form stars in the future. Feedback, both radiative and mechanical, is sculpting the structure of NGC 6240, from the core to its extended halos. At large scales, tidal tails stretch like cosmic claws, remnants of the galaxy's initial collision. These arcs of stars and gas are filled with young star clusters, some only a few million years old, others already dissolving into the galaxy's halo. These structures hold the fossil record of the merger's beginning, a frozen choreography of gravity. Meanwhile, deep X-ray surveys show that the hot halo of NGC 6240 extends far beyond its visible boundaries, glowing in temperatures of millions of degrees, a plasma-rich environment reminiscent of galaxy clusters. IC 4623 and NGC 6240 represent opposite ends of a spectrum, one quiet and enigmatic, the other explosive and extreme. Yet both are shaped by the same forces, gravity, time, and entropy. They are not exceptions in the universe, but living illustrations of how galaxies breathe, collide, and transform. From obscured black holes to radiant shock fronts, from dust-veiled nurseries to high-energy outflows, these galaxies remind us that the cosmos is not still. It is always in motion, turbulent, evolving, and alive. In the aftermath of such cosmic collisions, the universe does not retreat into silence, it reinvents itself. The wreckage of past stars, scattered across thousands of light-years, becomes the raw material for future generations. Heavy elements, carbon, nitrogen, iron, once forged in the hearts of long-dead stars, are now embedded in collapsing clouds, setting the stage for new solar systems, planets, and perhaps even life. This is the paradox of galactic violence, it destroys and creates simultaneously. In IC 4623, the process is quieter but no less profound. The subtle asymmetries in its spiral arms may be the faint echoes of an ancient interaction, perhaps a dwarf companion once brushed past, distorting its form and stirring up the interstellar medium. Today, this galaxy emits soft infrared signatures of renewed activity, hinting at an invisible battle between gravity and gas pressure in the depths of its core. Dust, often seen as a sign of decay, here becomes a cradle. Shielding fragile molecules from harsh radiation, it enables chemistry to unfold in the dark, hidden corners of the galactic womb. When viewed in the mid-infrared by JWST, IC 4623 reveals structures too delicate to capture in optical light. Loops of dust, faint arcs of gas, and knots of stellar formation glimmer against the blackness. They resemble the threads of a cosmic tapestry woven by time and turbulence. No human eye could ever see this directly, but now, through the eyes of our machines, we become witnesses to the galaxy's secret life. Meanwhile, NGC 6240 teaches us how chaotic systems achieve balance. Its double nuclei are not just future black holes, they are engines of regulation. As they devour matter, they inject vast energy into their surroundings, stabilizing the galactic core and halting uncontrolled star formation. It's an ironic dance, the more these black holes consume, the more they prevent runaway growth. Astrophysicists call this self-regulation, a principle that appears again and again in the evolution of galaxies. But this balance won't last forever. The twin black holes will eventually merge, releasing a final crescendo of energy. The central region may then settle into a more typical elliptical core, enveloped in aging stars and expanding shells of gas. Over billions of years, the galaxy may quiet down, cooling into a redder, older state, a far cry from its current fury. And yet, even then, it will carry within it the memory of its past. The tidal tails, star clusters, and metal-rich gas will remain as fossilized evidence of its cataclysmic youth. Future civilizations, perhaps orbiting stars born from these collisions, may look back at their origins and trace them to this very moment of chaos and fusion. Because galaxies are not just islands of stars. They are records. Archives of cosmic memory. Living organisms on a grand scale, shaped by forces as gentle as light and as violent as gravitational collapse. When we observe them, when we decode their structure, their light, their chemistry, we are not just looking into space. We are reading the autobiography of the universe. Even as we peer deeper into these galactic behemoths, we find that their complexity only grows. NGC 6240, with its smoking cores and chaotic halo, is not just a merger in progress, it is a fractal of motion. Inside it, stars orbit stars, clouds orbit cores, and the entire galaxy spins through dark matter scaffolding we cannot see but must imagine. Simulations suggest that during such mergers, gravitational torques rip apart galactic disks, funneling vast rivers of gas into the nucleus, triggering the very starbursts and AGN activity we now observe. These are not isolated fireworks, they are governed by cosmic mathematics written into the fabric of space itself. As JWST and Chandra continue to dissect this system, we find ever finer details, stellar nurseries caught mid-collapse, shock fronts lit by ultraviolet radiation, jets of plasma twisting like corkscrews from the accretion disks of the twin black holes. These observations are not just beautiful, they are essential clues to how galaxies evolve, how black holes grow, and how energy reshapes structure on scales millions of times larger than any solar system. IC 4623, by contrast, plays a quieter symphony. But still, it pulses. Analysis of its rotation curve suggests the presence of a massive dark matter halo, extending far beyond the visible light. This invisible mass governs the galaxy's dynamics like a ghost hand. It keeps the spiral arms stable, balances the distribution of stars and gas, and binds the whole structure into coherence. Without dark matter, IC 4623 would fly apart. With it, it survives in a slow, majestic drift through the intergalactic sea. Dust lanes, barely visible in shorter wavelengths, become luminous in the infrared. These dark veins carry the molecular raw material of stars, seeding the next generation of stellar birth. In a sense, galaxies like IC 4623 are cosmic midwives, nurturing, sheltering, and protecting the future. And though it may not explode with the drama of NGC 6240, its role in the galactic ecosystem is no less vital. Together, these two galaxies, one explosive, the other ethereal, offer a glimpse into the full range of galactic expression. From roaring mergers to whispering spirals. From violent jets to silent dust. They show us that the universe is not a static painting but a kinetic, evolving symphony. A place where matter and light are constantly rearranged, rewritten, and reborn. And as we look at them, we look into mirrors of our own existence. For we, too, are made of galactic ashes, atoms forged in stars that once exploded, molecules assembled in dust that once drifted between the arms of spiral galaxies. Every iron atom in our blood, every calcium molecule in our bones, once floated through galaxies like IC 4623. Every breath we take carries oxygen that may have been forged in the crucible of a collision like NGC 6240. To study galaxies is to study our ancestry on a cosmic scale. It is to understand not just where we are in space, but where we are in time. Each image from Hubble, from JWST, from Chandra, is not merely data, it is a message from the past, encoded in photons that took tens or hundreds of millions of years to reach us. A message of transformation. A message of continuity. Even more remarkable is how these galaxies, despite their violent or quiet nature, obey universal principles that connect them across time and space. At the heart of both IC 4623 and NGC 6240 lies the same engine, gravity. This fundamental force sculpts everything, from the orbits of stars to the swirling maelstrom around supermassive black holes. But gravity alone cannot explain the full story. It is the interplay between gravity, turbulence, radiation, magnetic fields, and dark matter that crafts the rich diversity we observe. In NGC 6240, gravitational chaos reaches its peak. Two black holes, each weighing over 100 million solar masses, are drawing ever closer. As they do, they stir the surrounding gas into violent eddies. This gas, accelerated and compressed, heats to millions of degrees and emits intense X-rays, a process that makes this galaxy glow like a cosmic furnace. Chandra's high-resolution imaging has revealed expanding bubbles of gas, superwinds, pushed outward by radiation pressure and jets. These bubbles can reach up to 30,000 light-years in diameter, sweeping up gas, stripping smaller galaxies, and enriching the surrounding space with metals. This is galactic-scale feedback, the galaxy regulating its own growth through energy. Yet despite the outward chaos, simulations suggest an underlying order. As the two black holes spiral in, they lose energy through dynamical friction and gravitational wave emission. At some critical distance, these black holes will enter the final parsec problem, a zone where traditional models once predicted a stall. But recent high-resolution simulations now show that asymmetries in the gas and stars can allow the black holes to continue sinking inward, overcoming this barrier and eventually merging. When that happens, the burst of gravitational waves will ripple across the cosmos, perhaps detectable by future instruments like the space-based LISA observatory. Meanwhile, IC 4623 teaches us about galactic stability. Its star formation is modest, yet persistent. Infrared maps show that much of its star-forming regions are hidden behind curtains of cold dust, where protostars slowly ignite. ALMA observations may reveal the detailed chemistry of these clouds, molecules like carbon monoxide, formaldehyde, and even complex organics drifting in zones that mimic the conditions of the early solar system. These are the slow alchemies of galactic life, chemical factories that work in silence over tens of millions of years. The structure of IC 4623 also hints at a bar, a central linear feature of stars and gas that may help channel material toward the galactic nucleus. This slow migration of gas feeds not only new stars but potentially a central black hole, much smaller than the monsters in NGC 6240, but still capable of flaring under the right conditions. Such bars are now thought to be crucial to long-term galactic evolution, acting as conduits of angular momentum redistribution, shaping spiral arms, and regulating the galactic clock. Both galaxies, in their own way, illustrate the idea that galaxies are not isolated, they are part of a cosmic ecosystem. The metal-rich winds of NGC 6240 may eventually drift into intergalactic space, where they can be captured by smaller galaxies or contribute to the chemical evolution of future structures. IC 4623, too, likely had interactions in its past, a minor merger, perhaps, that shaped its current form and set off slow waves of star formation. These interactions are the norm, not the exception. In the cosmic web, galaxies tug on one another constantly, exchanging matter, energy, and even destiny. With every new telescope, every new data release, we get closer to decoding the choreography of galaxies. From JWST's delicate mid-infrared tracing of starbirth to Chandra's X-ray vision of black hole violence, and ALMA's molecular whisperings from cold dust, we are now watching the universe write its story in multiple wavelengths. Each one reveals a different voice, a different tempo in the symphony of creation. And somewhere, in the cold, vast silence between stars, galaxies like IC 4623 and NGC 6240 continue to evolve. Quietly, furiously, patiently, beyond the reach of time as we know it. As we widen our lens beyond the visible, these galaxies begin to speak in wavelengths we cannot see, but can now interpret. Radio telescopes detect synchrotron emission from high-energy electrons spiraling along magnetic field lines, mapping the invisible threads that bind matter in motion. In NGC 6240, these magnetic fields are being twisted and amplified by the merger, threading through shocked gas and perhaps even influencing the direction and collimation of jets. Their presence shapes the flow of plasma and the birth of stars in subtle, yet powerful ways. Without them, many of the galaxy's spectacular features, its hot lobes, its bipolar outflows, would collapse into chaos. In contrast, IC 4623 emits softly in submillimeter wavelengths, where cold gas and dust reveal their quiet architecture. Here, we glimpse the scaffolding of stellar nurseries long before they light up the sky. Molecular clouds tens of light-years across drift in graceful arcs, balanced by gravity and internal pressure. Some regions show filamentary structures, long, thread-like condensations of gas, very similar to those observed in the Milky Way's own star-forming regions. These threads are not random, they align with magnetic fields, creating natural channels for collapse and fragmentation. It's in these filaments that stars are born, not in chaos, but in ordered, delicate equilibrium. But what connects both galaxies most profoundly is not just their matter, it is their time. Each one is a fossil of different epochs. IC 4623 is a survivor, possibly billions of years old, rotating slowly in a relatively quiet part of the cosmos. Its stars tell a chemical story of gradual enrichment, less oxygen than the Milky Way, more nitrogen in specific regions, suggesting slow, extended star formation. NGC 6240, by contrast, is mid-catastrophe, a galactic teenager caught in a growth spurt, tearing itself apart and reshaping its identity. In a billion years, it may resemble IC 4623 more closely, a calmer, elliptical remnant of something once violent and bright. This temporal layering is one of the most profound insights astronomy offers, that looking across space is looking back in time. The light we see from NGC 6240 left 400 million years ago, when Earth's continents were in different places and mammals had just begun to diversify. IC 4623 is even farther. Its photons have traveled through cosmic voids, past clusters and filaments, carrying with them a snapshot of a galaxy as it was in a time before human history began. Every telescope becomes a time machine, every observation a page torn from the cosmic archive. And as we study these galaxies, a pattern emerges, a cosmic dialectic between chaos and order, destruction and creation, silence and explosion. They are not opposites, but phases of a single process. Gravity draws matter together, feedback blows it apart, and in that endless push and pull, stars form, elements fuse, black holes grow, and light is born. Eventually, NGC 6240's black holes will coalesce into one, and gravitational waves will ripple outward like a final breath. IC 4623 may capture a passing dwarf galaxy, triggering new spiral waves and a renaissance of star formation. And over timescales beyond imagination, these galaxies will drift through the dark, quieting, cooling, dimming, until they fade into the cosmic background. But even then, their atoms will live on, recycled into new systems, new planets, new forms of life. Maybe even into the hands that someday build instruments more powerful than JWST, into the minds that look farther still. Because to gaze into galaxies is not merely to study stars. It is to study the story of transformation. It is to recognize that we, too, are part of this cosmic evolution, not spectators, but participants made of the very dust that drifts through arms of galaxies like IC 4623, born of the violence at the heart of systems like NGC 6240. In the sting of Scorpius, the universe remembers its own becoming. And in that remembrance, it whispers the deepest truths of existence, not in words, but in the language of structure, motion, and light. What NGC 6240 shows us, with its clashing halos and double hearts, is that destruction is not an ending. It is a phase transition. When galaxies collide, they do not vanish, they transform. The ordered disks are torn, yes, but out of that chaos emerges a new equilibrium. Stars that once circled peacefully in thin spirals now fall into randomized orbits. Gas, shocked and compressed, gives rise to new stars at furious rates. The black holes, once separate monarchs of their own galactic kingdoms, are now bound in a final spiral dance. This transformation is violent, but it is natural. Without such mergers, the universe would be sterile, no elliptical galaxies, no central starbursts, no great black hole mergers to ripple the geometry of spacetime. And even in IC 4623, with all its delicacy, the same pattern plays out more subtly. Spiral arms are density waves, cosmic traffic jams where stars and gas compress briefly, triggering bursts of formation. Dust lanes trace these wave fronts, like fingerprints pressed into the galactic disk. And at the very center, just perhaps, a quiet black hole stirs. It does not blaze like those in quasars or in NGC 6240, but its gravitational influence is real. It shapes the innermost orbits. It gathers the future. All of it, light, dust, structure, held in a delicate, dynamic balance sculpted over billions of years. From the outside, both galaxies seem still. But this is an illusion born of our short lives. In truth, galaxies are alive with motion. Stars orbit at hundreds of kilometers per second. Gas clouds collapse, ignite, and disperse. Magnetic fields twist and reconnect. Even dark matter, though invisible, flows and flexes, guiding every particle like an unseen conductor. Over cosmological timescales, galaxies breathe. They inhale material, convert it to light, and exhale energy and metals into the cosmic sea. And we, observers clinging to a small planet in the outskirts of a quiet spiral arm, have found ways to listen. We build instruments to detect what we cannot see. We model with equations what we cannot touch. And by comparing galaxies like NGC 6240 and IC 4623, one screaming, one whispering, we begin to understand the cosmic cycle that gave rise to everything we are. It is a cycle without a single author, but with an elegant, persistent logic. Gravity collapses. Fusion ignites. Radiation flows. Entropy spreads. And yet, in all of this, there is emergence. Patterns rise from chaos. Beauty arises from physics. Consciousness, perhaps the rarest structure of all, awakens in scattered corners of the cosmos to reflect on the galaxies that birthed it. So when we look at the Scorpion's tail, not just at its stars, but into the deep galactic structures hiding beyond, we are looking at something greater than an image. We are looking at a mirror of processes that span time, space, and form. We are reading the slow poetry of matter. And in galaxies like these, torn and whole, young and old, dim and ablaze, the universe speaks. Not in static perfection, but in its endless becoming. And this endless becoming is not random, it is orchestrated by laws so precise and universal that they hold true across billions of light-years. Whether in the warped core of NGC 6240 or the serene spiral of IC 4623, the same constants govern the dance, the gravitational constant that pulls stars inward, the speed of light that limits their communication, the fine structure constant that shapes the interaction between light and matter. These constants form the backbone of the cosmic symphony, unchanging rules in a universe of constant transformation. Yet within those rules, infinite diversity blooms. In NGC 6240, we witness entropy accelerating. Energy is being rapidly redistributed, from ordered orbits into chaotic flows, from structured disks into amorphous plumes. And yet, out of this entropy comes emergence. Super-star clusters, packed with thousands of massive stars, form in the compressed gas between the colliding galaxies. These clusters will live fast and die young, enriching their surroundings with supernovae, metals, and shock waves. Some of them may survive as protoglobular clusters, fossils of the collision that will orbit the resulting galaxy for eons. Others will be torn apart, their stars scattered into the growing galactic halo like cosmic pollen. In IC 4623, entropy unfolds more slowly, like the gentle spiral of a fern uncoiling. Its stars form in more isolated clusters, its dust lanes evolve gradually, its central regions rotate in harmony. Here, we see the slow chemical evolution of a stable galaxy, the gradual buildup of metallicity, the enrichment of gas by asymptotic giant branch stars, the cooling of the interstellar medium through fine structure lines of carbon and oxygen. It is a quiet life, but not a static one. Even in stillness, the galaxy ages, changes, adapts. It remembers. In a way, every galaxy is an archive. A library not of words, but of light, motion, and time. The shapes of spiral arms preserve the memory of past interactions. The abundance of elements tells the history of stellar generations. The velocity of stars reveals the hidden distribution of mass, both visible and dark. And the structure of galactic halos, vast and elusive, speaks of early epochs when matter first collapsed into structure. The galaxies of the Scorpion constellation, IC 4623 in its tail, NGC 6240 near its burning heart, are not just celestial objects. They are time capsules. They are laboratories. They are sculptures of spacetime, formed by processes that operate from the quantum scale of particles to the gravitational binding of entire clusters. And perhaps most mysteriously, they are also messengers. They remind us that even in chaos, there is design. Even in collapse, there is renewal. Even in darkness, where dust hides light, where black holes consume everything, there is information, creation, and continuity. A kind of cosmic resilience. A will to evolve. To understand these galaxies is not just to decode physics. It is to trace the lineage of complexity itself, from hydrogen clouds to star clusters, from nuclear fusion to carbon chemistry, from dust to DNA. It is to see the long arc of becoming that leads from ancient collisions to human curiosity. And as we tune our instruments toward the Scorpion's sting, we're not just hunting light from the distant past. We are listening to our own origin story. Written in starlight. Inked in dust. Etched across billions of years by the hand of the cosmos. And so, as we follow the trail of light from IC 4623 and NGC 6240, we begin to perceive the broader architecture of the cosmos, not as a static backdrop of stars, but as an ever-evolving web of relationships, governed by feedback, shaped by symmetry, and animated by motion. These galaxies do not exist in isolation. They are nodes in a vast cosmic network, filaments of dark matter stretching across the observable universe, binding groups and clusters like neural pathways in a brain made of stars. In this web, galactic evolution is not linear, but recursive. Star formation leads to black holes. Black holes drive outflows. Outflows enrich intergalactic space. Enriched gas cools and collapses into new stars, which, in turn, seed future structures. It is a cycle of transformation far grander than any biological life cycle, one that operates on scales of millions of light-years and billions of years. And yet, we now realize, it is deeply connected to our own. Because in truth, galaxies are crucibles of consciousness. Without the chemical complexity forged in ancient stellar cores, no life could ever arise. No oceans. No neurons. No observers. Every molecule of DNA, every cell membrane, every synapse, is made from atoms born in fire, the remnants of galactic violence now breathing through us. The Scorpion's galaxies embody this paradox in full. Take NGC 6240, in it, we observe the final, fevered breaths of two massive galaxies, devouring, distorting, radiating. And yet, their destruction is a kind of cosmic birth. The merger will form an elliptical galaxy far more massive, more luminous, and more metal-rich than either of its predecessors. Its central black hole, once two, will now be one, spinning faster, heavier, perhaps surrounded by a new accretion disk formed from the torn remnants of its hosts. And from its edges, winds and radiation will continue to sculpt the cosmos around it, long after the merger is over. We can even trace the cosmic chemical fingerprint left by these events. Observations show elevated levels of elements like neon, sulfur, and iron in NGC 6240's central outflows, proof that generations of supernovae have exploded in its heart. These metals, driven outward at thousands of kilometers per second, will enrich nearby dwarf galaxies, alter the thermal balance of the intergalactic medium, and one day, perhaps, fall back and reignite future star formation. IC 4623 offers a subtler form of storytelling. Its calm spiral arms, captured in detail by the JWST's mid-infrared camera, show signs of secular evolution, a slow transformation driven not by collision, but by internal instabilities. The possible presence of a central bar, a structure formed by collective gravitational resonance, may be funneling gas toward the core, gradually building a pseudo-bulge. This is a form of growth not through trauma, but through balance. And yet, even here, we see echoes of ancient interactions, perhaps a long-ago minor merger, or a flyby from a now-dissolved satellite, perturbed the disk just enough to spark the spiral. In both cases, these galaxies reflect different phases of galactic life, the starbursting adolescence of NGC 6240, and the mature, structured calm of IC 4623. And just like biological organisms, galaxies age. They form stars, exhaust fuel, lose angular momentum, quench, and fade. Yet, they never truly die. Their matter is recycled, their light echoes through the cosmic microwave background, and their black holes remain, ancient gravitational anchors marking the places where galaxies once lived. We are beginning to understand that even black holes themselves are not just endpoints, but gateways of information. Though they trap light, they encode the mass, spin, and charge of everything they consume. And through Hawking radiation, however subtle, they may eventually evaporate, returning their energy to the universe in the final chapters of cosmic time. The black holes at the centers of IC 4623 and NGC 6240 may outlive their galaxies, their stars, even their atoms. But perhaps the most profound insight these galaxies offer is this: the universe is not indifferent. It is responsive. Structures emerge where there is tension. Beauty arises from imbalance. Complexity flows from turbulence. And in that interplay, observers like us appear, tiny, fragile, and yet capable of decoding the light of galaxies that existed long before Earth was formed. We chart their orbits. We simulate their mergers. We count their stars. But we are also, inevitably, drawn into their stories. Because when we look into galaxies, we see not only what they are, but what we came from. From the dust lanes of IC 4623 to the screaming nuclei of NGC 6240, the universe speaks in a language of structure, motion, radiation, and memory. And in learning to read that language, we step beyond the limits of our world, into a shared history that spans galaxies. A history still unfolding. As we dive deeper into the inner workings of galaxies like IC 4623 and NGC 6240, we begin to see them not just as cosmic islands, but as dynamic, multi-layered systems, each layer governed by a different set of physical principles, each interacting with the others in subtle, astonishing ways. At the macroscopic scale, gravity reigns supreme. It dictates the orbits of stars, the shape of spiral arms, the collapse of gas clouds, and the formation of galactic structures. But as we zoom in, we encounter turbulence, magnetic fields, radiative transfer, and plasma dynamics, processes that weave a complex tapestry of order and chaos. In NGC 6240, these processes are in overdrive. The violent interaction between its progenitor galaxies has turned its interstellar medium into a furnace. Gas is compressed by shock fronts and turbulence. Enormous tidal forces stretch clouds into filamentary streams, while gravitational instabilities fragment them into dense clumps, stellar nurseries on the edge of collapse. Infrared data reveal compact starburst regions where hundreds of stars are forming simultaneously within a few light-years, a level of intensity thousands of times higher than in the Milky Way. This is not smooth, gentle star formation. It is chaotic and unstable. Many of these stars will be massive, burning hot and fast before ending their lives as supernovae, injecting heavy elements and kinetic energy into the surrounding gas. The cumulative effect of thousands of such explosions can blow entire cavities into the galaxy's halo, driving galactic winds that escape into intergalactic space. These winds are visible in both X-ray and optical emission, streaming outward like ghostly arms, carrying with them the ashes of stellar death. Such outflows serve a dual role. They quench future star formation by expelling gas, but they also enrich the cosmic environment with metals that future generations of stars, and potentially planets, will inherit. In this way, NGC 6240 is not just reshaping itself, it's altering the chemical evolution of the universe. Meanwhile, IC 4623 offers a controlled laboratory for studying quieter, longer-lived evolutionary processes. Its rotational velocity curve flattens at large radii, revealing the gravitational influence of an extended dark matter halo. This invisible structure, composed of exotic particles we have yet to detect directly, holds the galaxy together. Without it, the spiral arms would wind up and disperse. Dark matter is the silent architect, shaping structure, stabilizing disks, and forming the gravitational scaffolding upon which all luminous matter hangs. In its central regions, IC 4623 may harbor a low-luminosity active galactic nucleus, AGN, a faint, intermittently active black hole surrounded by a torus of dust. These quiet AGNs are difficult to detect, but mid-infrared observations hint at warm dust and weak ionization lines, suggesting that accretion is taking place, albeit slowly. This raises fascinating questions. How often do normal spirals like IC 4623 undergo periods of nuclear activity? Could many quiet galaxies be home to dormant giants, black holes slowly feeding, waiting for the next inflow of gas to reignite? Beyond the disk, the galactic halo of IC 4623 may be populated by ancient globular clusters and streams, relics of past interactions with smaller galaxies. These faint stellar arcs, detectable only through deep, long-exposure imaging, offer clues to the galaxy's hidden history. Each stream is a scar, a signature of a past accretion event, showing that even the most peaceful-looking galaxies are built from merger hierarchies over billions of years. On yet smaller scales, both galaxies exhibit rich chemistry in their cold gas clouds. Observations using submillimeter arrays like ALMA have detected complex organic molecules, methanol, formaldehyde, even prebiotic precursors, in dense molecular clouds. These molecules are the seeds of astrobiology, hinting that the chemistry necessary for life is not unique to the solar system but is widespread across the cosmos. Galaxies are not just engines of stars, they are factories of molecules, many of which may eventually end up on rocky planets orbiting stable stars. And through all of this, gravity, chemistry, radiation, there is time. Cosmic time. Time measured not in years, but in epochs. From the initial collapse of gas into protogalaxies, through mergers and starbursts, to eventual fading and quenching, galaxies trace a life cycle every bit as intricate and majestic as that of a living organism. Some become elliptical husks, filled with red giants and low activity. Others spiral on, sustained by slow gas accretion from the cosmic web. Some are consumed. Others grow by feeding. Each one follows a different path, but all are chapters in the greater narrative of universal evolution. And as we map this story, using instruments that extend our senses across the entire electromagnetic spectrum, we realize, we are not outsiders looking in. We are participants. We are made of galactic memory. IC 4623 and NGC 6240, one serene, the other ablaze, are not simply distant lights in the sky. They are reflections of what the cosmos is capable of. They are proof that the universe creates structure, complexity, and perhaps even meaning from its own raw laws. And they remind us, above all, that every atom in our bodies was once part of a star, once adrift in the dust lanes of galaxies like these, now given form only briefly, to witness, to wonder, and to seek answers among the stars. As we continue decoding the anatomy of these galaxies, we come to a deeper realization: galaxies are not just objects, they are processes. They are not frozen snapshots but dynamic systems, flowing through cosmic time, constantly exchanging energy, angular momentum, and even identity. Their visible stars are merely the surface. Beneath that lies a complex interaction of multi-phase gas, dark matter halos, turbulent feedback cycles, and the subtle influence of cosmic environment. Take, for instance, the circumgalactic medium, CGM, the vast halo of diffuse gas that surrounds every galaxy, including IC 4623 and NGC 6240. Though faint and difficult to detect, the CGM is now understood to be one of the most important components of galactic evolution. It acts as both a reservoir and a filter, feeding cold gas into the galaxy to form new stars, while also catching the winds and outflows driven by supernovae and active galactic nuclei. In NGC 6240, the CGM is ablaze. X-ray observations reveal a hot, metal-rich halo stretching tens of thousands of light-years, glowing at temperatures of millions of degrees. This gas is enriched with iron and silicon, clear signatures of Type II supernovae, which occur when massive stars end their lives in fiery explosions. These metals weren't born here, they were forged in stellar cores, blasted into space, and now swirl in the outer halo, waiting to cool and fall back in or to be swept into intergalactic space. This process is known as galactic recycling, and it is key to the longevity of galaxies. The material expelled today may return millions of years later, reigniting star formation in a new epoch. The CGM is thus not just a passive halo, it is a living system, connecting the internal metabolism of the galaxy to the broader cosmic web. In contrast, the CGM of IC 4623 is likely cooler and more stable, filled with neutral hydrogen and ionized carbon, gently cycling gas in and out of the disk. Instruments like the Cosmic Origin spectrograph aboard Hubble can detect the absorption lines of this gas when a bright quasar shines through it, acting like a flashlight illuminating the invisible. These studies show that even quiet spiral galaxies are surrounded by envelopes of gas hundreds of thousands of light-years wide, playing a vital role in regulating their evolution. But the most astonishing aspect of galaxies is their connection to the structure of the universe itself. IC 4623 and NGC 6240 are not isolated accidents, they exist within cosmic filaments, vast rivers of dark matter and gas that thread across the universe like a neural network. These filaments feed galaxies with cold streams of gas, guide their motions, and sometimes even direct their collisions. Recent cosmological simulations, like Illustris and TNG, show that the direction of galaxy spins, the shape of spiral arms, and the likelihood of mergers are all influenced by a galaxy's position in this cosmic scaffolding. NGC 6240's dramatic collision may have been orchestrated by the convergence of two galaxies along a filament, their trajectories destined to intersect. IC 4623's quiet isolation might be due to its placement in a low-density node, far from the violent flows of galactic traffic. And it doesn't stop there. These galaxies are also part of larger ecosystems, groups, clusters, and superclusters. NGC 6240 is believed to reside in a loose group of galaxies, where gravitational interactions are common and matter is shared over large scales. Such environments accelerate evolution, mergers happen more often, black holes grow faster, star formation becomes episodic and explosive. IC 4623, in a quieter neighborhood, evolves more slowly, its story written over billions of calm orbits. All of this, structure, chemistry, dynamics, is bound by one deeper question: what is the ultimate fate of galaxies? Do they burn bright and fade into elliptical embers, like NGC 6240 will after its merger is complete? Do they spiral on in quiet cycles of renewal, like IC 4623, until their fuel is slowly depleted? Do they fall into clusters, lose their gas, and become red and dead? Or are there cycles we don't yet see, ways galaxies might be reborn, refed, reactivated across timescales we can scarcely imagine? The answers lie not only in observation, but in pattern recognition across scales, from quantum mechanics to cosmology. Galaxies mirror processes we see in biology, in geology, even in thought: stability and disruption, decay and regeneration, feedback and emergence. And perhaps most fascinating of all, in studying galaxies, we are not just learning about the cosmos, we are learning about systems thinking, about complexity, about how order emerges from entropy. Galaxies like NGC 6240 and IC 4623 are more than beautiful, they are intelligent in structure. They adapt. They respond. They self-regulate. They embody the deepest laws of physics in forms that glow, pulse, and breathe across the darkness. And we, as observers, made of their atoms, guided by their light, are a product of that same intelligence. To observe them is to recognize ourselves. To map them is to map memory. To listen to their light is to hear the ancient rhythm of a universe becoming aware of its own form. As we reach deeper into the heart of galactic evolution, we begin to uncover the most extraordinary realization: the universe is not merely a place where matter gathers, it's a system that learns how to organize itself. In galaxies like IC 4623 and NGC 6240, this self-organization manifests not only in structure, but in cycles of feedback, resilience, and recursive adaptation. These aren't just chaotic accumulations of gas and stars. They are cosmic ecosystems, balancing energy inflow and outflow, responding to perturbations, and continually restructuring their internal states. Let's start with one of the most mysterious agents shaping galaxies: feedback. In the violent starburst nucleus of NGC 6240, feedback is extreme. As massive stars explode in supernovae and black holes inject energy through jets and winds, the surrounding gas becomes overpressurized. This leads to the launching of galactic superwinds, powerful, large-scale outflows of gas that escape the galaxy's gravitational pull. These winds, traveling at thousands of kilometers per second, strip galaxies of their star-forming material, potentially halting future growth. Yet, paradoxically, some of this material later cools, condenses, and falls back, triggering new waves of star formation. This loop, positive and negative feedback interwoven, is a hallmark of self-regulating systems. It's similar, in principle, to how Earth's climate balances incoming solar energy with atmospheric processes. On galactic scales, the same principle applies: if star formation accelerates too rapidly, feedback kicks in and tempers it. If the activity drops, gas cools and returns, allowing growth to resume. This balance is not perfect, it oscillates, but over cosmological time, it allows galaxies to maintain dynamic equilibrium. In IC 4623, the feedback is gentler but no less important. Its central black hole, though quiet now, may experience flickering AGN phases, short bursts of accretion lasting thousands to millions of years. These mini-episodes can heat surrounding gas, ionize clouds, and prevent premature collapse, keeping the star formation process steady and regulated. This is known as maintenance mode AGN feedback, a slow-burning engine that sustains galactic stability. The ability of galaxies to regulate their internal thermodynamics, cooling rates, accretion flows, star formation efficiency, is what allows them to persist for billions of years. Without it, they would either burn too fast and collapse into quiescence, or become so dilute that gravity could no longer bind them. It's this delicate tension between expansion and collapse that gives rise to the spiral arms of galaxies like IC 4623, and the turbulent shells of merger remnants like NGC 6240. But structure isn't just a product of gravity and energy, it's encoded in geometry. The spiral arms of IC 4623 aren't solid structures, they're density waves, patterns moving through the disk, compressing gas as they pass, igniting star formation in rhythmic intervals. This leads to stellar age gradients along the arms, newborn stars near the leading edge, older stars trailing behind. It's not chaos, it's wave mechanics scaled to tens of thousands of light-years. Meanwhile, in the warped remnants of NGC 6240's collision, we find signs of shell galaxies, tidal arcs, and dynamically decoupled cores, all signatures of gravitational resonances left behind by the merger. These structures act like fossil imprints of past events, allowing astronomers to reconstruct the history of interactions based on geometry alone. In fact, Galactic archaeology has become a field in its own right, reading galaxies the way geologists read rock strata or paleontologists read bone layers. Beyond this, we now know that galaxies don't just evolve, they co-evolve with their central black holes. There's a profound correlation between the mass of a galaxy's bulge and the mass of its central supermassive black hole, known as the M-sigma relation. This suggests a deep connection. As galaxies grow, so do their central engines, and vice versa. The physics of this coevolution is still being unraveled, but it points toward a unifying principle in cosmic structure formation, a synchrony between the vast and the compact, the galactic and the quantum. And the implications stretch further still. Modern simulations now include not just gas and stars, but cosmic magnetism, radiation pressure, neutrino transport, even relativistic jet physics. These simulations, some run on the world's most powerful supercomputers, reveal that galaxy formation is not a mechanical process, but a complex dance of fields and feedback, of turbulence and symmetry breaking. We now recognize that galaxies are emergent systems. They arise not from single causes, but from the interaction of many components, each one operating across different scales of time and space. From quantum fields and black hole accretion disks to the vast flows of dark matter halos across the cosmic web, everything is connected. And it is through this lens that we must now view IC 4623 and NGC 6240, not as isolated case studies, but as expressions of cosmic intelligence, not conscious, but structured, responsive, and capable of memory. They remember in their stars, their chemical abundance patterns. They remember in their halos, the orbital paths of cannibalized satellites. They remember in their feedback cycles, the history of light, pressure, and time. And as we observe them, measure them, simulate them, we are also recording our place in that memory. For the iron in our blood, the calcium in our bones, the carbon in our cells, it all passed through this same network of cycles. It was born in galaxies like these. We are not merely observers of galaxies. We are galactic phenomena, momentarily self-aware. And the more we understand that, the clearer it becomes. To study galaxies is to study ourselves at scale. So as we step back and gaze once more at IC 4623 and NGC 6240, one serene and spiraling, the other erupting with cosmic fire, we begin to understand them not as distant curiosities, but as profound reflections of the universe's inner workings. They are manifestations of time, energy, and evolution. They are bridges between the invisible and the observable, between the quantum and the gravitational, between past and possible future. In their dust, we see the blueprint of creation. In their light, we read the echoes of ancient stars. In their structure, we trace the rhythm of cosmic intelligence, unfolding, responding, transforming. Galaxies are not just collections of stars. They are stories. They are engines of becoming. And we, born of their ashes, are the only known part of the universe that can look back and understand. To study them is not just to answer scientific questions. It is to remember where we came from. It is to recognize the patterns that made us. And it is to listen to the quiet voice of the cosmos, speaking across billions of years through spiral arms and black hole fire. You were always part of something greater. You still are.